Hello dear students, in this video lecture we are going to solve exercise 1.2 of your NCERT book. If you don't know what are the types of functions, that is what is one function, what is onto function, what is bijective function, then you can watch my previous video. Otherwise you can't understand the solution of this exercise. So let's proceed to the question number 1. Question number 1. So that the function f from r star to r star defined by f of x equal 1 by x is 1, 1 and onto, where r star is the set of all non-zero real numbers. And the second part is the result true if the domain r star is replaced by n with codomain being the same as r star. So this is our given function. So for 1, 1, first of all, we'll let x1, x2 belongs to R such that f of x1 equal f of x2. So we take 2 points from the domain of the function such that their images are same. If we find out these two elements are same, then we can say our function is 1, 1. So this implies 1 by x1 equal 1 by x2. So after cross multiplication, we get x1 equal x2. So by definition of 1, 1 function, we can say our given function is 1, 1. So therefore f is 1, 1. Again, for onto, let y belongs to r star codomain be any element, then we can write f of x equal y. Now we express this equation in terms of x. Basically we need to find the value of x in terms of y. So this implies 1 by x equal y. So this implies x equal 1 by y. And clearly this x equal 1 by y belongs to r star for any value of y. So we can write for all y belongs to r star, there exists x equal 1 by y belongs to r star. We can write like this because this y is an arbitrary element. This is any element. So for all y belongs to r star, there exists x equal 1 by y belongs to r star. So therefore f is onto. So hence the given function is 1, 1 and onto. Okay, now we proceed for the second part. So here our function is f from n to r star, f of x equal 1 by x, since this domain is replaced by n. So for 1, 1, let x1, x2 belongs to n such that f of x1 equal f of x2. So this implies 1 by x1 equal 1 by x2. This implies x1 equal x2. So therefore f is 1, 1. And for onto, let y belongs to r star be any element. Then we can write y f of x equal y. Now this implies 1 by x equal y. So this implies x equal 1 by y. And clearly this 1 by y does not belongs to n. Because if we take y equal 2, then you get x equal 1 by 2, and clearly 1 by 2 does not belongs to n. So for all y belongs to r star, x equal 1 by y does not belongs to n. So by definition of onto function, we can say our function is not onto. Here I write this example. You can give so many examples for which this x does not belongs to n. Now question number 2. Here we need to check injectivity and surjectivity of these functions. So here the given function is f from n to n given by f of x equal x square. So for 1, 1, let x1, x2 belongs to n domain such that f of x1 equal f of x2. So this implies x1 square equal x2 square. So this implies x1 equal plus minus x2. Therefore x1 and x2 are not always equal. So therefore f is not 1, 1. Again for onto, let y belongs to n codomain be any element. Then we can write y equal f of x. So this implies y equal x square. Now we express this equation in terms of x. So this implies x equal plus minus root over y, and this is clearly does not belongs to n because if you take y equal 2, then root over 2 does not belongs to n. So therefore we can write for all y belongs to n codomain, this x equal plus minus root over y does not belongs to n domain. So I write this example here. So therefore f is not onto. So in the second question, this is our given function. So this question is similar as the previous one. So here for 1 let x1 comma x2 belongs to z domain such that f of x1 equal f of x2. So this implies x1 square equal x2 square. So this implies x1 equal plus minus x2. So here also x1 and x2 are not always equal. So therefore f is not 1 1. Again for onto, let y belongs to z, which is codomain, be any element. Then we can write y equal f of x. So this implies y equal x square. This implies x equal plus minus root over y. And clearly this is does not belongs to z, because if you take the value of y is 2 or 3, then you get root over 2 or root over 3, clearly does not belongs to z. So therefore for all y belongs to z, this x does not belongs to z. So therefore our function is not onto. Again the question number 3, here the given function is this f from R to R, and it is given by f of x equal x square. So for 1 let x1 comma x2 belongs to R domain such that f of x1 equal f of x2. So this implies x1 square equal x2 square. So this implies x1 equal plus minus x2. So f is not 1 1. You can so this function is not 1 1 in another way also. If you take the value of x1 is 1 and the value of x2 is minus 1, then clearly f of 1 and f of minus 1 both are same, but 1 not equal minus 1. So we can say our function is not 1 1. Again for onto, let y belongs to R codomain be any element, then we can write y equal f of x. So this implies y equal x square. So this implies x equal plus minus square root of y. So this is does not belongs to R, because if you take the value of y is negative, that is if you take y equal minus 2 or minus 3 minus 4 something like this, then this x does not belongs to R. So for all y belongs to R codomain, x equal plus minus root over y, this is does not belongs to R. So I give this example, minus 2, y equal minus 2, then x equal plus minus root over minus 2. This is a complex number, so this is does not belongs to R. So therefore f is not onto. Next question number 4, this is f from n to n given by f of x equal x cube. So for 1 let x1 comma x2 belongs to n domain such that f of x1 equal f of x2. So this implies x1 cube equal x2 cube. So this implies x1 equal x2, because here the power of x1 and x2 are odd. So we can write x1 equal x2. So therefore f is 1 1. Again for onto, let y belongs to n codomain be any element, then we can write y equal f of x. So this implies y equal x cube. Now we express this equation in terms of x. So this implies x equal cube root of y. So this is does not belongs to n, because if you take the value of y is 2, then cube root of 2, it is clearly does not belongs to n. So therefore for all y belongs to n codomain, x equal plus minus cube root of y does not belongs to n, which is domain. So therefore f is not onto. Here the given function is f from z to z set of integers and given by f of x equal x cube. So for 1 1 Let x1 comma x2 belongs to z such that f of x1 equal f of x2. So this implies x1 cube equal x2 cube. So this implies x1 equal x2, since here the indices are odd. So therefore f is 1 1. Again for onto, let y belongs to z be any element, then y equal f of x. So this implies y equal x cube. So this implies x equal cube root of y, and clearly this is does not belongs to z, because if you take y equal 2, then cube root of 2 is not in z. So therefore for all y belongs to z codomain, x equal plus minus cube root of y does not belongs to z. So therefore f is not onto. So question number 3, prove that the greatest integer function f from R to R given by f of x equal greatest integer function of x is neither 1 1 nor onto, where the greatest integer function denotes the greatest integer less than or equal to x. So here this is our given function. So for 1 1 we have 1.4 comma 1.7 belongs to R. So now f of 1.4 is equal 1, because the greatest integer which is less than or equal 1.4 is 1, and f of 1.7 is equal also 1. So therefore f of 1.4 is equal f of 1.7, but 1.4 not equal 1.7. So therefore f is not 1 1. Again for onto, we know that f of x equal greatest integer function of x is always an integer. Therefore there does not exist any element x in R such that f of x equal 0.5, because if you take non-integral point from this set from the codomain, then this point has no pre-image in the domain. So therefore f is not onto. So hence f of x equal greatest integer function x is neither 1 1 nor onto. Now question number 4, so that the modulus function f from R to R given by f of x equal modulus x is neither 1 1 nor onto. So here to show this function neither 1 1 nor onto, we just give counter example. Solution, this is our given function. So this equal x if x greater than or equal 0, and minus x if x less than 0. This is the definition of modulus function. So for 1 1, clearly f of 2 equal 2, and f of minus 2 equal modulus minus 2, which is also 2. So here f of 2 is equal f of minus 2, but 2 not equal minus 2. So f is not 1 1. Now for onto, we know f of x equal modulus x is always non-negative. So thus there does not exist any element x belongs to R such that f of x equal minus 1. That means if you take the negative values from the codomain, then these negative values have no pre-image in the domain. So therefore f is not onto. So therefore f(x) equal modulus x is neither 1 1 nor onto. You can also show that modulus x is not onto in another way also. So I write here, since f of x equal modulus x is always non-negative, so therefore the range of modulus function is non-negative real numbers. This is 0 to infinity. So therefore range of f is not equal domain of f, because domain of f is set of real numbers. This is R. So hence f is not onto. Next question number 5. So that the signum function f from R to R given by f of x equal 1 if x greater than 0, 0 if x equals 0, minus 1 if x less than 0 is neither 1 1 nor onto. Here we also give some counter example to show that our given function is not 1 1 and not onto. So this is our given function. So clearly f of 1 equal f of 2 equal 1 because 1 and 2 both are greater than 0. So their images are 1, but 1 not equal to. So therefore f is not 1 1. Again, we know the range of f is -1, 0 and 1 because this signum function always gives only these three values. So this is the range of f. So thus there does not exist any element x belongs to R such that f of x equal to. If you take any value except these 3 points from the codomain, then you can't find the pre-image of that points. So therefore we can't find any pre-image of 2. So therefore f is not onto. So therefore signum function is neither 1 1 nor onto. Next question number 6. This is a simple question. Here these are given: a equal 1, 2, 3, and the set b equal 4, 5, 6, 7, and f equal 1, 4, and 2, 5, and 3, 6. This means the image of 1 is 4, and image of 2 is 5, and image of 3 is 6. So therefore f of 1 equal 4, f of 2 equal 5, and f of 3 equal 6. So here the images of distinct elements of A under f are distinct, because here images of distinct elements of A are distinct elements of B. So therefore f is 1 1. So question number 7. In each of the following cases, state whether the function is 1 1 onto or bijective. Here bijective means the function is both 1 1 and onto. Justify your answer. So this is our first question, number 1. This is our given function f from R to R and defined as fx equal 3 minus 4x. So for 1 1, let x1, x2 belongs to R such that f of x1 equal f of x2. So this implies 3 minus 4x1 equal 3 minus 4x2. So this implies we get x1 equal x2. So therefore f is 1 1. Again for onto, let y belongs to R codomain be any element, then we can write y equal f of x. So this implies y equal 3 minus 4x. Now we find the value of x. So x equal 3 minus y divided by 4, and clearly this term belongs to R for any value of y. So we can write for all y belongs to R, there exists x equal 3 minus y divided by 4 belongs to R, such that f of 3 minus y divided by 4 is equal y. So therefore f is onto. Since f is both 1 1 and onto, so we can write f is bijective. For question number 2, this is our given function, and for 1 1, let x1, x2 belongs to R such that f of x1 equal f of x2. This implies 1 plus x1 square equal 1 plus x2 square. So this implies x1 square equal x2 square. The 1 will be cancelled out from both sides. So this implies x1 equal plus minus x2. So here x1 and x2 are not always equal. So therefore f is not 1 1. Let y belongs to R codomain be any element, then we can write y equal f of x. So this implies y equal 1 plus x square. Now we express this equation in terms of x. So this implies x square equal y minus 1. So this implies x equal plus minus square root of y minus 1, and clearly this term does not belongs to R for all values of y. For any value of y, because if you take the value of y is minus 1, then you get minus root over minus 1 equal root over minus 2, and clearly root over minus 2 does not belongs to R. So therefore for all y belongs to R, x equal plus minus root over y minus 1 does not belongs to R. Here I give this example. So therefore f is not onto. Since f is neither 1 1 nor onto, so f is not bijective. So now question number 8. Let A and B be sets so that f from A cross B to B cross A such that f of AB equal BA is bijective function. So now here first of all we need to show f is 1 1 and then f is onto, and then we can say f is bijective. So here this is our given function. So for 1 1, let a1 comma b1 comma a2 comma b2 belongs to A cross B such that f of a1 comma b1 equal f of a2 comma b2. Now by the definition of the given function we can write b1 comma a1 equal b2 comma a2. So this implies b1 equal b2 and a1 equal a2. Since these two order pairs are equal, so their first components are also equal and the second components are equal. So if we interchange these two terms, then we can write a1 equal a2 and b1 equal b2. So this implies a1 comma b1 equal a2 comma b2. So therefore f is 1 1. Again for onto, let b comma a belongs to B cross A, be any element. Then we can write this B belongs to capital B and this A belongs to capital A. So this implies we can write A belongs to A comma B belongs to B. So this implies AB belongs to A cross B. So therefore for all B comma A belongs to B cross A, there exists A comma B belongs to A cross B. So therefore f is onto. So therefore f is bijective since f is 1 1 and onto. Question number 9. Here the given function is f from n to n and it is defined by fn equal n plus 1 divided by 2 if n is odd and n by 2 if n is even. State whether the function f is bijective. Justify your answer. So first of all we need to check whether the given function is 1 1 or not. So this is our given function. To check whether this function is 1 1, we take 1 comma 2 belongs to n from the domain. Then f of 1 equal 1 plus 1 divided by 2. Since 1 is odd, so we use this definition. So this equal 2 by 2 and this is equal 1. Again f of 2 equal 2 by 2. Since 2 is even, so we use this definition. So 2 by 2 equal 1. So we get f of 1 and f of 2 both are same, equal to 1. But 1 is not equal to. So here we can say our given function is not 1 1. So since our given function is not 1 1, so we can say the given function is not bijective. Here we no need to check whether our function is onto or not, because since a function to be bijective it must be both 1 1 and onto. But here f is not 1 1, so f is not bijective. But if you want to check whether the given function is onto or not, then you just see this portion. Here I check whether this is onto or not, and after simplification we get f is onto. Next question number 10. So here this is our given function f from a to b and fx equal x minus 2 divided by x minus 3, and here the set a is equal r minus 3 and set b is equal r minus 1. So consider the function f from a to b defined by fx equal x minus 2 divided by x minus 3 is f 1 1 and onto. Justify your answer. So for 1 1, let x1 comma x2 belongs to a such that f of x1 equal f of x2. So this implies we can write like this. So after simplification we get x1 equal x2. So f is 1 1. Again for onto, let y belongs to b, this is codomain, y belongs to b, then we can write f of x equal y. So this implies x minus 2 divided by x minus 3 is equal to y. So we can write x minus 2 equal xy minus 3y. So x equal 1 minus x into 1 minus y is equal 2 minus 3y. Now this implies x equal 2 minus 3y divided by 1 minus y. Here we express f of x equal y in terms of x. So here this value of x is clearly belongs to a for any value of y. Therefore, for all y belongs to b, there exists x equal 2 minus 3y divided by 1 minus y belongs to a. So therefore f is onto. Question number 11. Let f from R to R be defined as f of x equal x to the power 4. Choose the correct answer. F is 1 1 onto, f is many 1 onto, f is 1 1 but not onto, f is neither 1 1 nor onto. So basically we need to check whether f is 1 1 or not and whether f is onto or not. So this is our given function. So for 1 1, let x1 comma x2 belongs to R such that f of x1 equal f of x2. So this implies x1 to the power 4 equal x2 to the power 4. So this implies x1 equal plus minus x2 because here the powers of x1 and x2 both are even. So therefore f is not 1 1. Again for onto, let y belongs to R be any element, then we can write y equal f of x. So this implies y equal x to the power 4. So this implies x equal 4th root of y. And for x belongs to R, this x belongs to R, this y must be greater than equal 0. So this means the range of the given function is set of non-negative real numbers, that is 0 to infinity. So therefore range of f is not equal codomain of f. So therefore f is not onto. So our correct option is D, which is f is neither 1 1 nor onto. Next question number 12. This is our last question of this exercise. Let f from R to R be defined as f of x equal 3x. Choose the correct answer. F is 1 1 onto, f is many 1 onto, f is 1 1 but not onto, f is neither 1 1 nor onto. So for 1 1, let x1 comma x2 belongs to R such that f of x1 equal f of x2. So this implies 3x1 equal 3x2. This implies x1 equal x2. So therefore f is 1 1. Again for onto, let y belongs to R be any element, then we can write y equal f of x. So this implies y equal 3x. So this implies x equal y by 3. And clearly this y by 3 belongs to R for any value of y. So therefore for all y belongs to R, there exists x equal y by 3 belongs to R. So therefore f is onto. So the correct option is A. F is 1 1 onto. So thank you for watching the video.